record. Okay, so I'm going to start with, I will throughout the semester use different programs, different examples. If I use yours, don't get offended. If I don't use yours, don't get offended. It's for learning purposes. I almost always take the name out. I just randomly grabbed one, and it's one that I wanted to share. So I'm going to share this program. And we got a nice program. Looks good. Some documentation in there. It's light blue and so forth.
I'm sorry,
And it's
Professor, I
all
can't see your screen.
Can't
what's
see it.
that?
It
Yeah,
says you're
we
screen
can't
sharing, but
see.
we can't see it.
Hmm.
Well, now that's a problem. Share. Can you see it now?
Yes.
Yes.
Yes, yes. Okay, good. Program's great. There's a method for input. Excuse me, function for input, a function for calculation. And you're the programmer, and you got it down in your head. You know exactly what's going on in the program. Oh, dummy. Get back to sharing it again. You can see it again, right? So if I compile this program and it works, can you see the screen, the black screen?
No,
No. What am I missing? What am I missing? I
you
got
would need to
this.
Are you
tab and
sharing the like that application instead of the whole screen?
Oh, no. I want to share this. You can see it?
yes.
Yep.
Yep. So I'm going to start throwing some stuff out because I need to teach you now for down the road. Because what I have in 162, same thing's going now because they weren't taught in 161. This is boring. This is all you've known up to this point, but it's kind of boring. If you called your significant other over and said, here's a program, go ahead, they'd look at it and go, what? Please choose rock, paper, scissors. Okay, I choose lizard. What's going on here? What is this program? What is it? You know what it is because you're the program. Is this user friendly? Uh, okay, so I think I have to take, and again, whomever this is, and I'd say half of them look like this. Okay, so now I have to type CSI because I'm a slow typer. I'm a hunt and pecker. No, I'm not. I can type pretty fast. Scissors, enter. Please enter a valid. Okay, what did I typed it wrong. Um, Thinking outside the box. Could they have done 1, 2, 3, 4, 5? The other half of the class did 1, 2, 3, 4, 5. That's kind of nice. Okay. So anyhow, I put in scissors. The computer selected rock. You lost. Why'd I lose? I don't know what's going on here. Do does do I do know this one? Rock, dolls, scissors, or there's some kind of saying that goes along with it. Can we get a little fun in this program? Can we make it fun? I thought it was a fun program. You folks would be like, "Yeah, here we go. We're gonna do this and we're gonna do that." And okay, I ran it. This is kind of fun. I lost, so the computer's winning 1-0. Somebody actually had that. Somebody had the computers winning 1-0. Would you like to play again? Yes. They kept track of wins and losses. That person got extra points on their program for pizzazz. Would you like to run again? Yes. Oh, no. It wasn't required, but come on, man. We got some fun going on here. Rock, paper, scissors, lizard, Spock. We can, welcome to the game created by Big Bang Theory. Da 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 da. Lizard annihilates Spock because he spits a venomous poison in his face, and Spock is dead. Pizzazz, not pizzazz or huzzah. Pizzazz, user friendly. Dumb it down. I had one guy who would say, "Yeah, I took your advice. Every time I'd write a program, I'd say to my wife, 'Come here.' And she'd sit down and she'd say, 'Okay, I have an idea what you want me to do. You want me to make this nice for me.' Yeah. And then she'd say, well, can you do this? Can you do that? Can you do this? And have some fun with it. There's going to be programs where you say, choose rock, paper, scissors. So I touch rock on the screen and nothing happens. Oh, I get it. I have to type it in. I have to, can you give me an example of what it is I need to type? So just let's get them. Now, do you notice where the capital P is? It's where? It's up there in that upper left-hand corner, isn't it? Every one of your programs was where? Up there in that upper left-hand corner. Can you start to do some indenting? Can you put blank lines in? Can you put clear screen in if you're going to run again? And I'm not saying I required that. I'm now saying, here's what I want you to do from now on. Is there a way to change it from a black screen in the back and fun letters and colors in the front? Could I? Okay. So I want these to be a little easier for me, more friendly for me. Remember, I'm grading 23 of them. Who's just going to stick out? Who's going to get that extra 4 points because I don't do extra credit, but I give bonus points on a program because it had pizzazz and I liked it. And a lot of that stuff you can get in one program and copy and paste to the next because your favorite background is dark blue. You want the letters to be white. Comments. Again, that program got 20 out of 20, but now it's time. You got to sell your programs, right? I try to make fun programs. I was like, yeah, this is a fun program. They're gonna have fun with it, and then they're gonna make their friends play. Hey, come here, just like that TV shows, right? Kind of thing. There's also one that has nuclear explosion, cockroach, and foot. Like a foot can stamp on a cockroach, but a cockroach can live through a nuclear explosion, but a nuclear explosion will kill the foot. And so, okay. Anything at all. All right. Piston is now here. That's good. Here we go. Chapter 7. I got stuff here. I got stuff over there. I got stuff here. I need my book. Chapter 7, code listings. Bam, you did 12 of them. Lots of good stuff on getting those points. I got the last 2 right before class started, but that's 12 out of 12. You take this test on Wednesday, which is harder points to get. Does that make sense? Code listings are the easy guaranteed points to get. People skip code listings and then they don't do well in the test and they can't cover for. Do the easy points. Don't forget them. I have to be truthful and say most of you are doing a really good job with submitting code listings. Like just about everybody's getting them done and they add quick. Okay. Easy stuff. We're going to go through arrays. I'm going to switch my camera. I'm going to use the book today because most of this you should know. And if I stood there and was writing it on a chalkboard in front of you, you would be going, oh my gosh, this is so boring today. But I don't have to be boring because I'm reviewing and I need you to get programming. Here we go. Recording, view, a speaker. That's me. Hi, everybody. That's the camera I want. Okay. Arrays and vectors. We're going to get through the first 7 sections here in about 20 minutes. It's not bad. Next week, we're going to get into these vectors. The week after that is spring break. Oh, my goodness. Arrays. Arrays are something that's called static. Okay? Because I would say, hey, I want you to create an array. And you'd be going, okay, here's the size of the array. Let's go. And then you'd work with it. It's static. A vector is an introduction of a new concept called dynamic, where you don't run out of room. Okay? Why don't we always use vectors? Because static is much easier to work with. Arrays are a lot easier. In 162, vectors are gone, and we learn of something else that's dynamic that works really cool. We don't have time to get it in this course, so we start out with vectors. Okay, so we had a bunch of code listings, but I'm going to run through a couple of things first. And I'm going to come in here, and of course you see this array, and we have our elements. This is num sub 0, num sub 2. You're good with all of that, but what is, in this case, well, up here, this is days. This is days sub 1. Now, I need you to understand, because this concept carries over to a bunch of other things. What is the difference between days and days sub 1? This is the way we're going to think about it from now on. We've never done this before, have we? We've never looked at the name of the array. What is the name of the array? Anybody have a wild guess? Days is the address where the arrays start. So days is something. As I said, we're going to start working with a lot of addresses in this course. Days is something. It says this is an address. The subscript sub 0, the subscript 1. In this case, it says go to the address days and move over 4 bytes times 1. This was 0, it would say go to days, go to the address. It's an int, 4 bytes times 0. That would give me that first element in the array. Since it's integer, here is 2. It would say go to the array address and move over 2 times 4 bytes. Move over 8 bytes to get me to the start of where I want. So this is like work. This is a memory address. This is telling me where do I need to shift to once I get that memory address. So we're taking what you had in CPS 121 and upping it a little bit. Memory requirements. Short only takes 2. So I would be taking my subscript times 2. Char is 2 bytes. So knowing and having a little bit of an idea of what size these data types are, it's going to help us when we're working with these arrays. Okay, nice and easy. That's the new thing, 7.1, bam, we come in, we create it just like we did in Java. Piece of cake. 7.1, check. 7.2 is doing the same thing. We're going to start to see some differences. Here's one. You had this terminology before. It's called implicit initialization, where this is constant. I don't need to fill the array with something that the programmer doesn't know. The programmer knows this. And if the programmer wants to fill it right away, bing, 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 it fills the array right away. This array days has these values stored in them. And again, 31 is in the first thing. It's in a block of 8 bytes. 8 bytes is holding the value, 4 bytes and 4 bytes and holding the value of 31 in there. Yeah, that's just a couple of lots of zeros and then some zeros and ones over here. Okay, so we do once again have that implicit initialization. Another thing we have is this. Oh, here we go. Partial initialization. Do you notice that this array is of size 7? At number sub 0, it's a 1. Number sub 1 is a 2. Sub 2 is a 4. And sub 3 is an 8. We want to make sure we get those starting values in. What's going on up here? What was I doing in a class and I wrote these numbers? This next number is 5. This next number is 8. The next
Fibonacci.
yeah, it's the
sequence.
Fibonacci sequence, and I may want to put the first 2 numbers in. Fibonacci sequence is generated with 0 is the first number, 1 is the second number, the next number is the sum of the previous 2. The next number is the sum, and it just keeps going. Fibonacci sequence. There are people that argue the first two numbers in the Fibonacci sequence are 1 and 1 instead of 0 and 1. I don't know. My bud Fibo's not around anymore to ask him, so I can't really say, "Hey, Fibo, what's going on?" Hey, oh, here we go. 7-7. Oh, I got stuff lit up and all ready to go. In the world of programming, a lot of what you do is the world of big data, reading in big data. Well, this isn't big data. This array is only of size 10. But what if I had 1,000 pieces? I create my array size of 1,000, and then I'm going to get ready and read it in. But I love this example. This is a really good one because it's loaded with some good syntax for C++. What do I have? Okay, I'm working with an array. I should probably have highlighted line number 3. Did you ever think about in the beginning of your notebook, if you take notes, like today, you could write down program 77 dash opening a file and filling the array and making your own index of quick notes that you scan down and say, oh, I want to find where an example of yada, yada, yada. Oh, this is a good one. I used to have students get those little arrow sticky notes and write and then put the arrow in there so they could flip to that page quick. But this is a good one. All right, using FStream. I'm going to get ready and I'm going to get input file. So I'm creating a thing called an object. Chapter 7 in 121, you dealt with objects. We're going to create an object. My object is called input file. A method that works with it is open. Basically, what's happening here is my object is now connected to the file 10numbers.txt. And you all know if it's not in the same folder, you have to put the path, all kind of good stuff. That URL. What's URL stand for? URL.
Is it Universal Resource Locator?
No, Universal Resource Locator. Thank you. Okay. So, but anyhow, you'd have to type that all. Yeah, I'd have to type it in to go find a file. I'm just going to put them together. Some of you probably ran this and never did the 10 numbers, made a text file up with 10 numbers, which you could do in seconds. All right, I'm going to come in and let's see my loop control variable is working with input file. I get an initial value, I have a check, and I have an update. So I have a nice little loop going on here. Two things I'm checking. More and more, you'll find that when you're doing a while loop, you may need two things. One, to make sure I don't flood my array. I don't want to keep reading things in because unlike Java, where we used to get an index out of bounds, C++ doesn't give a rip. It's just going to let you make a mess of it. Okay, so I need to make sure I don't input more than 10. I have a counter for that. And input file is where I'm going to go to. This is nice. This goes and grabs the value, the next value out of input file, stores it right in my array. Bam. Just like that. Bam. Emeril Lagasse used to have a cooking show. Whenever he'd add garlic, he'd holler, Bzim. But yeah, you guys don't like garlic. Questions? I like code listing 7.7. All right, arrays. We're good with arrays. 7.9. Yeah, this program was a crazy one. Why? Warning, Will Robinson. If you compile and run this program, it could crash because we're trying to use up more than what we allot. We allot 3. Storage for 3 integers. We're trying to fill them with 100. Oh boy. You typed it in, Did it crash for you? What did it do?
It didn't crash.
Yep.
It displayed 5 things. The fourth one was 100. The fifth one was 4. So then I played
Probably.
around with it again, and then based on whatever the array size was, the first outside of that was a 4, and then the one after that was like the numerical limit, like 214 something million
It's
something.
whatever's in that memory location. There's probably junk in there. So that's what it just went and read the next 4 bytes and converted it into a number.
Cool.
Oh, look at us just going. There's no bounds checking. Here we go. I used to cross this out, but I cover it now. I should do this. We cover it now. Yeah, we cover this. Couple of things going on. We are using this terminology, range-based loop. Range-based, okay? It takes my stuff down here, my for loop, and it presents it in a smaller, shorter type of syntax. I have an array of 10 to 50. Line 11 for int val numbers. And we'll talk about that in a second. Do you notice I have int crossed off and int put up here? There are pros and cons to where you put this. You can put it here, but I don't think those of you who are using bloodshed, this will work. I don't think it's supported. So you would have to yank it out. I don't even know if range base is supported. But here's what, well, let's see what's going on here. Something's going on. I'm coming in and I have a variable. And a lot of folks say, well, you know, every time it hits this line, it creates a new memory location. So that's doing extra work instead of having one. On and on and on. This is saying go to numbers, which we know is an address, and input it and store it in val. Now, what's going on? There aren't any subscripts. How's it know which one to do? Tell us. Well, it knows we have an address. Every time we read one in, +1 gets added to this address. That +1 is going to be 4 bytes. So when it's read, it advances to the next one. Some of you in my 121 class, remember we had a giant data file. We had to open it and count how many there were, but we had to read it in to advance to the next one. This automatically advances to the next one. This is, again, in your notes, some kind of shortcut. Nice. Boom. If you want to use it, it's quick. It's one of those, if you're going to use it so you get good at it. Otherwise, don't, because no soup for you. You'll mess it up once in a while. We have another one. This time we're dealing with the string array, reading it into a string. Cool, nice. Blocks of code, blocks of code. The more code I see, the better I can do. Oh boy. Oh boy. You typed this in, right? Did you do 712? Does it look familiar?
We didn't do 712, I don't think.
Not.
No.
Create an array called numbers. Boom. I come in and yeah. Oh boy. Oh boy, what's going on? What is this?
A reference variable?
Yeah, it's getting the address. This is the address. So right now the address is being stored in numbers, from numbers, and I'm going to read a value in. when I read in val, it goes to that address. So the first time val, when I read it in, is going to get stored in number sub-zero. Whoa, that's heavy stuff. This might be easier. See out, enter a value, see in, number sub-counter. This is, again, we're leading into working more and more with addresses and reference variables. I wanted to point out that example, so you had a peek see at what it looks like. Okay, good, good. 7.5 processing rate. We're going to do that in just a little bit. 7. Yeah, you should know how to do this. Finding the highest and the lowest values. Most efficient, most common way is highest gets the first value. Then we go from 1 to less than size. If it's highest, highest gets number sub-count. You did it in 121. Should have been on your test in 121. It's just one of those common ones that we do. The other thing is highest could equal 99999, something really big, and then go from 0 up. Excuse me, highest could be negative 999, because then the first one would definitely be bigger and we'd fill it. But this is nice this way. We don't have to know a limit. You good with that, Taylor? Taylor said, oh yeah, keep going, keep going. Da-dee-da.
I love arrays.
What's that?
I said I love arrays.
That's good. I like to hear that. Okay. Here's an array. Here's an array. Line. Oh, it doesn't have line numbers. This if statement is comparing the, not the arrays, it's comparing the addresses. Okay? It's comparing the addresses. You need to go element by element by element, which is over here. And again, I don't have to write all this down. You should be fairly familiar with all of it. We have to do that deep comparison instead of just the addresses. Okay, 7.7. Finally, a little meat today. Here's what we got. Pass the name of the array. So I'm going to be calling some functions and I'm going to have arguments. And I have something like, what's my prototype? I have an int, which means I'm just passing the int. 7.16 is kind of boring. We know I'm passing the value that's here. Good. We don't want that. We want 7.17. This is one of those good blocks of code to have. I have an array called numbers. I am calling show values. I'm passing in the address of numbers. Size is 8. So when I come down here, I need to store the address. And where do I store it? I create another array that can get that address value. Okay. Here it is in the prototype. Here it is in the function header. It's in its parameter list. We can go and fill it, and the new values are going to stick. Reference variable. What if I say, hey now, I don't want to screw this up, right? What could I put inside of there? Do you remember?
Constant.
Constant, yeah. And I think that may have shown up in this 7.19. Oh my, when a reference variable parameter gives it, that's what we just said. Here I know in my prototype, the last one we just looked at was a function. It's just a straight function without a prototype. How does it look with a prototype? Boom, I'm going to be passing in an array of integers. Get ready to work with 4 bytes. Okay, good. I have an array called set. Bam. I'm passing set in to show values. I'm passing the address over. It's got to land in some sort of integer array. So this is in the prototype. Boom. This, the address is in the function call. The address gets stored in a new array that's being created. Three slightly different ones. The prototype didn't have a name here. The function call only had the array name, and here it's all together. With me? Yeah, man. Good. I know this is a pretty good class, and you like me to get you to typing. So I'm going to get you to typing. Okay. Here we got screenshot. Take a picture with your camera if you need to. Do whatever you need to, but make sure you get it. Page 10, number 457. Want you to do that program. I want you to do that program with those three functions. One's called get answers. That's going to be an array. One's called correct answers, which you can put in implicitly. You can declare this array implicitly. That's all the correct answers for what's going on page 457 in your C++ hymnal. Do 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 do. Bam. Whoop. Bam. Okay. You can store this implicitly. Quote A quote, quote D quote, quote B quote, quote B quote, and on and on and on. So you don't want to be typing these in all the time. In fact, how many might you want to do to start this program while you're still working on it? I might just do 5 of them and then ask for the users 5 and compare. Do I want to be inputting the users 20 every single time? Say no, not right now. Once it's up and working, then I can change it to 20. But for now, I might just shorten it up to 4 or 5. Here's the correct answers. You are going to input the student's answers. Go from there. How many correct answers were there? Give them a percentage. Make it something nice. Again, I would work with small array first. Get it to work. That's the first program. I want these 3 functions. I'm passing in an array, passing in an array, and passing in an array. Okay, this is an input. This is the comparison. You notice I'm returning a value using a reference value. I'm going to send it to display. You can do that. You're in really good shape in this class right now. Second one, do Fibonacci. Fill the Fibonacci sequence. Boom, great. Let's put 10 numbers in. This starts to get big quick. Then you're going to ask the user, hey, I want to know, which term would you like to see? They could pick the 5th term. You would display the 5th term. This one's okay. This one's a good one to get that up and running.